Question 1. Find the inverse of the matrix 2, 5, 3, 4, hence otherwise solve the equation 2x plus 5y is equal to 9, 3x plus 4y is equal to 6. The matrix that you have been given is 2, 5, 3, 4. The first step to get the inverse of any given matrix is to get the determinant. The determinant is gotten by taking the values in the main diagonal. The main diagonal is occupied by the elements 2 and 4. So we multiplied 2 times 4 minus 3 times 5. This determinant will be 8 minus 15, which is equal to negative 7. Then we can use the rule that for any matrix, A is equal to A, B, C, D, then A inverse is given by 1 over determinant of A into D A minus B minus C, meaning that for us to get the inverse of any matrix, we take 1 over the determinant into, for the main diagonal, we change the values, we interchange them, so that the place where there was A, we take D, where there was D, we take A. The other diagonal, which is occupied by C and D, we don't interchange them. However, we change the sign that they are having. Likewise, inverse of two, 5, 3, 4 is also given in the same way. We take 1 over determinant. Our determinant is 7 and it is negative. Into the main diagonal, we interchange the values so that we have 4 and we have 2. The other diagonal, we just change the sign, but we don't interchange the values. When we open the bracket, we are going to get the inverse, and the inverse will be given by 4 over 7 negative 1 over 7 times 5 is equal to 5 over 7, 3 over 7, then negative 2 over 7. We have gotten the inverse of the matrix. We have been given a simultaneous equation, which is 2x plus 5y is equal to 9, and also 3x plus 4y is equal to 6. When you are given simultaneous equations to solve using matrix method, you must first of all write the simultaneous equation in matrix form. In the column of x, we have 2x and we have 3x. So you put them in the same row so that we have 2 and we have 3. Likewise, we have 5y and 4y. We also put them in the same column so that we have 5 and 4, because all of them are y. Then we look at our equation between x and y. In each of the equations, x is coming first, so we write x, then we write y. Then the answer to this is given as 9, 6. You also write it in matrix form. Then, in order to solve a simultaneous equation using matrix method, we take the matrix of the simultaneous equation, we pre-multiply it with the inverse of that matrix, but because the matrix looks exactly the same as the matrix that we are told to get the inverse, when we pre-multiply the inverse with the matrix, the inverse of a matrix and the matrix, we usually get an identity matrix. So the concept that we are going to use is to pre-multiply the matrix of our equations with the inverse of the matrix that we had gotten. To pre-multiply means we start by multiplying, we start by writing the inverse first. So when you pre-multiply, therefore, we are going to have negative 4 over 7, 5 over 7, 3 over 7, negative 2 over 7. This is the meaning of pre-multiplying. Because we are writing this first, is when we write 2, 5, 3, 4. And because you're solving equation having x and y, we must write x and y. The other side also, we pre-multiply. So whatever we do to the left, we must do to the right. Over 7, 3 over 7, 5 over 7, negative 2 over 7. We also here pre-multiply, meaning we multiply first before putting the matrix that was there originally. Now the right hand side, when we pre-multiply a matrix with its inverse, we usually get an identity matrix, which is 1, 0, 0, 1. And we have x, y. For the other side, we are going to multiply each term. So that means we are going to have negative 4 over 7 times 9 plus 5 over 7 times 6. Then the lower one for y will be 3 over 7 times 9 plus minus 2 over 7 times 6. Identity matrix times a matrix is equal to the same matrix, because identity matrix is equal to 1. It maps the matrix at the same point. So to the left side, we're going to have xy is equal to negative 6 over 7. Then for y, we have 15 over 7. This clearly indicates that x is equal to negative 6 over 7 and y is equal to 15 over 7, because x is occupying the same position that negative 6 over 7 is occupying, and y is occupying the same position that 15 over 7 is occupying.